So that was basically the first 2 minutes. You're on the rocket boosters for 2 minutes. Then you continue with the main engines, and the external tank is the propellant for the main engines for another 6.5 minutes. So 8.5 minutes from liftoff to time in orbit. And then once you get in orbit, then we start reconfiguring, opening the payload bay doors for cooling, start getting out of our seats, and getting ready to spend time on orbit. And this is our destination in space. That's the International Space Station, pretty much as it looks right now in space. When I was out there for my second flight, it wasn't quite as built out as it is now, but it was pretty well built out. I put this in here. This was actually from my first flight. This was the piece of the external truss that I brought out. But the reason I show this in here is because about 6 months after they launched this component on the other side, on the starboard side of the space station, they noticed they were having problems. The solar arrays are packed in here. In these two big arms are solar arrays that they're 100 feet long, but they fold up into about a 18-inch box. Here's the mast for the solar arrays, and so it's all packed up so it fits in the shuttle. Right in here was this big rotary joint, which once we got it operating in space, it allows the solar arrays on the outside of the space station to keep tracking the sun, so you don't have to constantly maneuver the whole station, and it allows you the most efficient way of generating electricity, whereas not using a lot of propellant of having to maneuver the space station. Problem they had after they launched the component on the starboard side, about 6 months after it had been in orbit, they noticed that it wasn't working properly. They started noticing high current draw on the motors. The crew inside was telling the ground that every time they ran it, there was a lot of vibration. And so they sent crews, they had a couple of shuttle crews, and they said, well, go out there and take a look. There's covers on it to protect it thermally from the environment, and so they went out there, took the covers off, and this is what they found. And even though it's kind of a dark picture, but this surface right here, just inboard of the teeth, is where the bearings sit. And if you know anything about bearing surfaces, bearings usually like to be on a nice smooth surface because they're rolling, and this is not nice and smooth here, because it turned out that they suspect that there was a material defect coupled with the fact that the lubrication scheme that they had planned was inadequate. And so what had happened is that it was crumbling. The outer surface was hardened, and so it was crumbling that outer surface. And what it did is all that metal was generating all of this dust. This is all metal, which looks somewhat magnetized because it is a steel, and so that was creating them problems. So now they had this piece of hardware in space that basically failed, and they couldn't run it, they couldn't rotate the arrays, and so they're trying to figure out, okay, what do we do with it? Because they had launched the Japanese and the European modules, they just hadn't launched all the equipment that goes inside for the scientific experiments, but this was going to limit their ability to generate electricity. They would still be able to generate to sustain the station, but once they start getting more experiments up there, you need more power, and so that was a big concern. Our flight had just got announced when they discovered all these problems, so we had about a year to work with the engineers. Were trying to figure out what happened and what could they do to try to remedy the situation. And if a year sounds like a long time, in the space world, a year is not a long time, because they like to test everything before they go outside, and it's very difficult to test things for the space environment. From the time they discovered the problem, they had about 3 shuttle flights, and there was a crew on station that they could send out, have them look at things, kind of test little bits and pieces, but at the same time, we were planning for our flight. So we had a very compressed schedule. And it turned out the answer ended up being as simple as clean up the dust, replace all the bearings, put new bearings in there, and then we're going to grease the surface. And the reason they didn't use grease to begin with is because when they planned this hardware, when they started designing it 10 years ago, they weren't comfortable with the long-term use of grease in space. They didn't know, would the grease break down? What was it gonna? How was it gonna react in a vacuum for a long period of time? But since from that time they started designing it to the time that we flew, grease was really their only option. By then we had started getting a lot more experience using it on various equipments. Smaller pieces of equipment outside did have grease, and there wasn't a problem, so they got comfortable using the grease. And so that was our plan. We're going to clean it up, and by putting in the grease, even though we weren't going to make that bearing surface back to a nice smooth surface again, but it was going to give them a good enough surface, because one of the advantages of being in zero G is you don't have gravity, so you don't have the same loading as you do on the ground. So that was a plan. So we went out there, and this was going to take us about 4 spacewalks to go out there and do that. And so we had to go out there, and going out there, one of the problems, the grease was somewhat problematic, because what we found out is, even though they had tested it in space, and even before they launched it, all the containers of grease, we took them, they put them through a vacuum test, so they knew how it would react in a vacuum, make sure there was, try to get all the gas out of it, because gas in space ends up becoming, it's a motive force, and so we found that out the hard way, because I reached into a bag to get another piece of equipment, and I noticed there's grease inside the bag. I thought, uh-oh, this is not good. And couldn't find where the grease was coming from, because it turned out you didn't need a lot of grease. All you had, probably my guess was about a piece of grease about this long probably came out. They took a gun that's very similar to a caulk gun that you would fix your bathroom with, and modified it for use with grease. The only problem with the grease is that they put a little shutoff valve on it, but the shutoff valve was well greased. And so it did not take much effort to hit the lever and open the valve. And then and you got a little gas pocket inside the grease, and you go out into the vacuum, and if it gets close enough to the end, now the gas starts expanding, it pushes the grease out, and it goes out the end of the tip. And then there was a cover on the end of the tip, but the cover had seams, and the seams all met at the end. And so the grease actually got forced through the seams. And it was just something that they didn't, even though they had taken the guns out before, they didn't have them out as long as we did. And so by keeping them outside longer, that's when we noticed the problem. And so that's when as I was cleaning up all the grease, trying to keep the mess, it was one of these bags. Oh, picture doesn't look too good, but it's a bag probably about the size of my computer. I had it in my hand, cleaned it off, and then I let it go. And as you let it go, you see it floating away. And you just go, uh-oh. And so that was not exactly my highlight in space, but it was, it really teaches you something about how do you handle, a mistake happened. And you can go back and figure out, okay, why didn't you tether it, and what happened, and then there's a whole history of you learn with mistakes. It's never one thing that will cause the final failure. It's usually a lot of things stack up. But the lesson was, okay, you had this failure. Now what are you going to do? And you figure out a way around it. And it turned out that by being out there, we actually figured out a better way to clean up the grease than what our plan was. Because it turned out our plan didn't work it worked well, but it just created a lot more grease. And so since we didn't have as much, because I lost half of it, you had to be conservative. And it turned out, well, that was good enough. And so you have to, there's this healthy balance, as there is in anything with engineering. Engineers like to be very precise and get things really, really exact. And quite often in real life, there's the balance between what's good enough and you just go move on. Or do you have to make sure it's perfect? It all depends what it is. doesn't mean that you can go out and say, oh, this is good enough, I don't have to be perfect. But sometimes you do have to be perfect, but sometimes it, you know, you got to get the job done. And if it's better to be, you know, 99% and get the job done. And so luckily we did get the job done, and they were very happy, because in addition to the repairs that we were planning, they did look at trying to replace the ring outside, and it would have been about $60 million plus 2 shuttle launches to get the equipment up there, and plus about 10 spacewalks to go outside and actually do the work. And then they were, you know, and so nobody wanted to go down that path, and so they were very happy that we actually got to the point we did. And within about 6 months of testing on orbit, they said it was almost back to the, as you know, the previous condition. So they were very, very happy with that. On the rest of the mission, in addition to fixing the outside, we brought a lot of supplies up to the space station. We had a cargo carrier in the inside of the shuttle, and we brought up about 14,000 pounds of equipment. And one of those pieces of equipment is, we call everything we call in orbit, we call them racks. You know, it's all the equipment fits in this standard case, and it's, you know, about the size of a refrigerator. You know, weighs about 1,000 pounds, but in space there's no gravity, so you can very easily maneuver it. But one of the things that NASA's trying to do on the space station, one of the reasons we have the space station up there, is to start looking at new technologies that we'd use to go beyond low Earth orbit. You know, if we want to go back to the moon, or we want to go to Mars, there's a lot of things we need to learn. You know, we're by no means ready to go off to another planet at this point. So this piece of equipment is a water recovery system, and it allows the space station to recycle water. And so they can take they can take condensate that comes out of the cooling system, and they can also take urine from the toilet system and run it through the water recovery system, and they can recover about 85% of the water, which is a good thing if you're going to go someplace where there's not a lot of water. So one of my crewmates liked to call it his coffee machine. He said you could take yesterday's coffee and turn it into today's coffee. And it works very well. They we brought it up. We had some problems trying to get it to run in the on station. We were able to fix the problems. We had replacement parts, so we had to change out some of the components, and we took back a whole bunch of water samples, and then the shuttle after us brought back some more water samples, and everything was working fine. And when they tested it on the ground, they said that the water quality was actually better than what you found in most municipal water systems. So it is actually very good water. This is just a short video that we made of living in space and what's it like. And there's one point in the shuttle or on the station you can go 4 different ways, and so you just have to be careful of who's coming and who's going. This is the shuttle's middeck. So down on the shuttle, it's definitely more crowded than it is on the space station. And that's where the shuttle crews, we live, we eat, we sleep, we exercise. When I was up there were only 3 members on the space station crew, and we swapped one out. We had Thanksgiving dinner on board. So there's our delicious Thanksgiving dinner, complete with turkey and candied yams and cornbread stuffing. Nice thing about space, you can play with your food. Yeah, and Don did something neat. He made his own cup that the liquid doesn't float out of it. And so I tell kids that when that's your physics problem for the day, is to figure out what does the cross section of the cup need to be so it doesn't float out. And then at the end we left our patch on board. But people always ask me, so what do astronauts like to do in their free time? And of course we make home videos to show people. But the greatest thing is just looking out the window. Is because it's just such a spectacular view to look out at the Earth, and you realize that there's a lot of water on the planet, so it's very blue, and there's a lot of clouds, and so it's really hard to figure out where you are because you don't see these nice lines all over the planet. But if you can find something that's easily recognizable, you can. Like the east or west coast of the United States was pretty easy to find, and then if you can figure out where you were. There was one day on my first flight, I was looking out the window, and I kind of looked out, and I said, that looks like the Black Sea, Czarne more. And I looked over on the computer, and yeah, that's what had us going over Eastern Europe. And I'm like, okay. So I looked over, and I found the Dnipro, and I traced it out, and we flew right over Kiev. So it was neat. Tried to find because my father's from a small village outside of Lviv, and it was just too hard to find Lviv because it's in the middle of land, and it's a lot harder to find. But it's a neat place to look and to be. The shuttle goes around the Earth it takes an hour and a half to go around the Earth. So we get a sunrise every hour and a half and a sunset every hour and a half. So about 45 minutes of day, 45 minutes of night. And this is how fast the sun comes up. Sun will come up in about 7 or 8 seconds in space. And you can tell after a while. When I was working outside, you get at sunrise, you'll start seeing that pinkish orangey glow from a sunrise, and then at night, when the sun's getting ready to set, if you look at the horizon, you just see this darkness stepping over the Earth, and okay, it's going to get night. And but like I said, it's just a beautiful planet, and I don't think I found any pictures that we've took. They're beautiful pictures, but it's just not the same as actually looking out the window. And I did take my ukrainski prapor with me, so you do find ways to take small mementos with you in space. But my second mission, after 16 days, it was time for us to come home. My first flight was 12 days long. So then, once you start packing everything back up and putting everything back in the places, and then you have to get back suited up in the launch and entry suits that are. That's something they added after the Challenger accident, so that if there was an accident, if we had an accident, that the crew module was intact, we could actually bail out. We have a parachute with us, we could jump out. And they like to have the shuttles land in Florida, but on my second mission, weather was bad in Florida, and it didn't look like it was going to be getting any better, so they just said, we're not going to keep you in space any longer. And so they sent us to California, to Edwards Air Force Base. And it was a beautiful day out there. That's Mission Control in Houston. They monitor us. After liftoff, Kennedy hands it off to Houston, and then Houston monitors us until we're on the ground. Very similar to an airplane, but when we come in, we're coming in much, much faster. Our touchdown speeds are usually about 200 knots. Mm-hmm. And an airplane is usually about 135, 140 knots, so we're much faster because we're much heavier, so we have to come in faster, and we don't have big wings like an airplane does. No engines at this point, and so it's just landing. It's energy management, trying to manage how fast you're going, how high you are, and where you need to touch down. And the guidance system on the shuttle does a fantastic job of getting us there. The pilot actually does land the airplane. They did design an autopilot into the system, but it's never been tested or used, so we've always had a pilot land it. So once we get on the runway, the parachute is just there to help slow us down on the runway. They found that the early shuttles didn't have a parachute, and it just helps take some of the load off the braking system so the brakes don't get too hot. Then we land, we roll out to the end of the runway. It takes about an hour or so to get out. It's always interesting trying to walk out of the shuttle because you've been in space for 2 weeks, and it makes a difference. And you come back and you find walking is really hard, and you find standing up is really hard. because you stand up and your vestibular system can't figure out, there's something wrong and it just doesn't know what it is, and you just haven't had gravity. The same thing happens when you go up. It's not uncommon on launch for people to go up and feel queasy the first couple of days in space. It's motion sickness. And it's just a different form of motion sickness. And then the same thing can happen coming back. It just takes a couple of days. They did a test of after my first flight. They do all the astronauts after your first flight to see how long it takes you to get back. And most people, by the third day, they're pretty much back to normal as far as your stability. And then it just takes you time to regain your muscle strength from not, having to walk and to run and things like that. The crew members that spend 6 months up on orbit, takes them a little bit longer when they come back. Some of them come back and have no problem at all. Other ones, they come back and as they like to say, gravity is not their friend. But the human body is able to adjust, and they too get back to normal eventually. So that's what I brought to show you. And if there's any questions, I'd be more than happy to try to answer them.
Thank you for a truly interesting presentation, and indeed we'll open it to questions.